Sing it for me. We're on. Fish on. Boom. Okay, now, can I do Q Twitch? Twitch.tv/Mr. D Burke. That's me. Yes, I am live. All right, let me share this out on the Twitters. Twitter.com. Am I signed into here? Does Twitch have an @? And I'm going to put it at in the Discord. If you're joining, as always, let me know in the chat what's happening. And if you can hear me. All right, who's ready to write some NLP code? Oh, thank you, Akash, for the congratulations on 80,000. I really appreciate the support from everyone on YouTube. All right, now today what we're doing, clean up notebook number 8, introduction for NLP. So I've got this natural language processing notebook here. And if we go to GitHub, my favorite website, TensorFlow Deep Learning, we are up to number 8 here. TensorFlow NLP Fundamentals, coming soon. So, introduction to NLP and TensorFlow. Let's get it going. First things first is we'll make sure that this code works. We need a GPU. Oh, Yuchi, reading the no competition post. I'm glad you enjoyed it, my friend. Something about I've been thinking about for a while. It's just, don't even bother competing. Just be you. Compete with yourself. If you compete too much, you become someone else. Downloading a data set. Upload this file to Google Storage. Have I not got this on Google Storage yet? I'm downloading it from Dropbox. Okay. Well, let's do that, hey? Let's get it on Google Storage. So, where I'm storing all the files for the console.google.cloud.google.com. Where I'm storing all the files for the TensorFlow course is on Google Cloud. Everything's so zoomed in. Oh, what am I getting charged for? Doesn't cost that much for storage. Beautiful. Okay, so I need to go to the storage buckets. ZTM-TF course. Food vision. And how about should I create a folder? I think I can just upload it to ZTM-TF course. So CD, TensorFlow course, ls. Oh, CD desktop. I wonder if I can just upload it to what's in data. LS, there's nothing in NLP project. Okay, it must be on Dropbox. Dropbox, ZTM. If you have any questions, always feel free to ask. Otherwise, I'm just going to start coding away and kind of commentating things as I go. Is it NLP getting started? Is that the link I'm using? Yeah, it is. Now I want to move this into the data directory. NLP getting started, wonderful. LS. And now we can upload this to Google Storage. GS util copy R NLP getting started .zip, and we want to upload it to GS ZTM TF course. Is that the bucket? Yes, it is. Clear. And now if we come back to the bucket, we should have NLP getting started. Wonderful. I'm going to make this public. Public. Copy URL. Boom. And then we want to also import helper functions that we've created. Get helper functions. So we can copy the code here from another notebook rather than. Don't repeat yourself, gentlemen, ladies. If you're writing code, just get around it. Ashik, what's going on, my friend? It's good to be back. Alex, French Toast, Mafia, what's happening? Hey, Shivans. Crashed into the stream. It's time for NLP. Yes, it is. So, just going to copy this from previous notebook. I've got lots of the code ready for the NLP section. So we're going to just walk through it today and make sure it makes a lot of sense. Probably stream for a few hours. It's lockdown where I'm living at the moment. We had a few coronavirus cases and our government decided, you know what? It's probably best we just lock it all down. So why not? And we want unzip data. Beautiful. Go unzip data. So how are we all? NLP. Did it work? It didn't unzip. Why did that not happen? Did I import unzip data? Oh, it did unzip. There we go. Sample submission. Now I need here, TK, this gives the files. Sample submission. Test.csv. Oh, they're all CSVs, aren't they? And train.csv. So we're getting this data set from Kaggle, which is the NLP getting started data set. Natural language processing with disaster tweets. So that's all we're doing. We're just using this data set, which is a good practice data set to start with, binary classification. And let's visualize it now. Once you've acquired a new data set, what do we move first? Of .csv files. So we're going to start to visualize it. Let me just show you the data set because that's much easier. Turn CSV files into pandas data frames. So we've got here ID, keyword, location, text, and target. So I believe it is the target column we're trying to predict. 1 is a real disaster tweet, and 0 is not a real disaster tweet. So we want to be able to predict whether a tweet is an actual disaster or not a real disaster. No lockdown on creativity, yes. Wow. It's state lockdown at the moment. Alex, you've been amazing. I'm running on a MacBook at the moment, Siobhan's. Ashik, you are absolutely killing it. Finished the TensorFlow course already. Shaking Basket says, do you think after completing the course you can do 1 or 2 Kathleen challenges? Kaggle challenges, you mean? Live? I've got a big plan after the course, so I need to focus on finishing the course. Okay. So now we have total training samples is 7,600, so tweets. Test samples 3263. And we have it's about 50-50 binary classification, but it's really about 60% negative and 40% positive. Okay, now let's visualize some random samples. Here we go. Boom. Not real disaster, not real disaster. Day 1 of the snow apocalypse. Might put a new line there. rect emotions. Okay, beautiful. Could we use train test split here? I believe we could. Rather than moving all of these. So if we go from sklearn dot, which module is it in? Model selection? I think it's in model selection, you know. Import train test split, and then let's get the doc string for train test split. Arrays. So I think we should probably use this function for that. That's probably a better idea, isn't it? Let's see why I didn't do that. Probably not going to do any Kaggle. Just I'm going to work on my own project. That's what I'm more interested in at the moment after the course. So let's get train sentences, train, no, what does it return again? Test sentences. No, test, train, val. There we go. Val sentences. And then we want train labels, val labels, equals train test split. And then we want to use train df shuffled. This is the X text. Y equals train df shuffled target. Okay, this is good. Test size equals, what do we want? We only wanted 90%. And then random state equals 42. Maybe I'll do the same random shuffling up here. Yeah, we've already got that. That way everyone has the same data sets when we're going through this problem. And let's shift enter on that. So this has to be an array. That might have been why I didn't use. This is going to return as a pandas series. Oh no, object. Can I do to array? Or as array? Or to array. That's maybe why I did it the other way around. To list. Haha. So what if I try this? At least one array required as input. I want to turn, what's the method for turning a pandas series into an array? Can I just call, is it just dot array? Of course it is. But will this work because it's strings? At least one array. What is going on here? Am I using the right variables here? Pandas array. Maybe I need as numpy, to numpy. Boom. Okay, it needs to be 2 numpy. I knew there was a way. At least one array required as... Hold the frickin' phone. Train df, shuffled, label, or no, target, to numpy. Yep, if you watch the latest TensorFlow videos, you can actually see in the videos, it tells you what you're going to cover. So the videos cover, so if you go to here, you can see part 1 contains 00, 01, and 02. Part 2 starts with part 1 off. So if you want to see the notebooks, the videos cover these 3 notebooks. The videos on YouTube. TensorFlow Fundamentals, TensorFlow Regression, TensorFlow Classification. Why isn't this working? Oh. It's a list inside an array? No, this should work. Doing some really hacky shit right here. Oh, I should stop swearing so much. These are both arrays. So why is this getting antsy-pantsy when I try to run it as array? Train test split. We don't cover recommendation engines. So it uses TensorFlow to build a regression model and a classification model, not a recommendation model. That's a different type of model. However, a lot of the steps that you need for recommendation, you'll need to know the TensorFlow fundamentals and TensorFlow regression as well as classification. Recommendation is it's kind of like a classification problem. Classify what someone would be interested in based on what other people have been interested in. But you could also phrase it as a regression problem too. But Netflix recommendation engine is, as you can imagine, very, very, very specific. However, I would just look up TensorFlow recommenders. There you go. TensorFlow recommenders. Look at that. This is what you come here for, to this stream. We don't cover recommenders in the course, but TensorFlow has a recommendation library, so you can just check that out. Okay, arrays. Maybe it's the... Huh. Uh-huh. Yes, my data is in an array. Come on, man. My data is in an array. What is happening here? Maybe I need to change the shape. I think I know. There we go, baby. You don't set x equals. It's a keyword argument. Daniel, you... See? Small little errors. Wonderful. There we go. Okay, we've got a training data set. TK. I'm going to make sure that this notebook runs end to end by the end of this stream, and then I'll upload it to GitHub. TK, write about what we're using to split data. Train test split. Converting text to numbers, yes. Yes, in NLP, there are two main concepts for turning text into numbers: tokenization character level tokenization, subword tokenization, embeddings. Now, Streamlad's OBS got an update. Okay, I noticed that my mic is getting in the way of my face. So I need to get some slides ready as well. Keynote. And make a duplicate of food vision. Actually, I can come back and make the keynote later. Now, is it still experimental? TensorFlow text vectorization. I believe it's still find average number of tokens in training tweets. Yes, look at that. Training data mapped. Now, let's try our text vectorizer on a custom sentence, one similar to what you might see. There's a flood in my street. So if someone said there's a flood in my street, you would expect that to be a disaster. No one likes floods. Too much water. But do you see what happened here? Is that this word, theirs, got turned into 264, and then A3 flood 232 in for my 13 street 698. All the rest is zeros. So that's what you want to do with natural language processing. You need some way to represent your text, your natural language, as numbers. And in our case, we've done a simple vectorization here. Now we can check the vocabulary. 10,000. Top 5 most common words. Space, unknown, or nothing. That's nothing. Empty string. The, A-N. Makes sense. Least common words. Pages, peds, pads, padres, Paddy Tomlinson, 1. Okay, now we can create an embedding with using we've got a way to map our text to numbers. How about we go a step further and turn those numbers into an embedding? A powerful thing about an embedding layer is it can be learned during training. This means rather than just being static, a word's numeric representation can be improved as a model goes through data samples. Yes! That is the benefit of embedding. We can see that what an embedding of a word looks like by using the TF Keras layers embedding layer. The main parameters we're concerned about here are input dimension, embedding. I got evacuated from the cinema 30 minutes through Inside Out. Kill me, please. What a great tweet. Get a random sentence from training set, and then embed the random sentence. Turn it into numbers. Hands-on ML is a great book. Each token in the sentence gets turned into a length 128 feature vector. Beautiful. So I'm going to put a slide for this one, I think. TK slide. Add a slide for feature vector for each word. Numerical representation. These values might not mean much to us, but they're what our computer sees each word as. When our model looks for patterns in different samples, these values will be updated as necessary. Yes, inputs and outputs. Now we've got a way to turn our text into numbers. We can start to build machine learning models to model it. Construct the model, train the model, make predictions of the model. TK, I'm going to have a slide. Experiments we're running. LSTM model, grew model, bidirectionally, LSTM 1D convolutional. We actually want to make sure beautiful. This is some good code right here. We don't actually need TensorBoard callback. Now, have the headings been updated here? Model 0, yes, 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 yes. The first deep model we're going to build is a single layer dense model. In fact, it's barely going to have a single layer. It'll take our text and labels and inputs, tokenize the text, create an embedding, find the average of the embedding, using global average pooling, and then pass the average through a fully connected layer with one output unit and a sigmoid activation function. If the previous sentence sounds like a mouthful, it'll make sense when we code it out. Remember, if in doubt, code it out. Oh yes. And since we're going to be building a number of TensorFlow deep learning models, we're going to create a TensorBoard callback function to measure the results of each. We'll import our callback function from helper functions.py to keep track of the results of each. Looking good. Our model takes a one-dimensional string as input. What GPU do we have? Now, I wonder if I can turn this into a TensorFlow dataset. tf.data. Let's try this. Equals tf data. There we go. For element train data set. I do want to learn more iOS. And I do want to build an app. There weren't any floods near me, no. Beautiful. Okay, I think we're on the right path. Train data set, batch 32. Okay, so this is overfitting a bit. I'm going to delete these, don't need that. But we know how to use it later. TensorBoard dev. Okay, we don't want to print out all of that. There's anything I've learned about printing out things in Colab is when you save them to GitHub, you don't want to print out every single thing. So oh, see, this is the value of using a baseline. So a good baseline for NLP models is TF-IDF, because very quick. Monkey learn. What's monkey learn? TF-IDF is a statistical measure that evaluates how relevant a word to a document in a collection of documents is. This is done by multiplying two metrics: how many times a word appears in a document, TF, term frequency, and the inverse document frequency of the word across a set of documents. TF-IDF is a great baseline. What's Monkey Learn? Like a cool website. Oh. Best text classification APIs. A guide to text classification using machine learning. Document classification. These are all very recent blog posts. Which text classification API is the best? Great way to promote your service is to write blog posts about it. Visualizing learned embeddings. Our first model, Model 1, contained an embedding which learned a way of representing words as feature vectors by passing over the training data. Hearing this for the first few times may sound confusing. So to further help understand what a text embedding is, let's visualize the embedding our model learned. To do so, let's remind ourselves of the words in our vocabulary. Yes. Get the weight matrix of the embedding layer. These are the numerical patterns between the text and the training data set model. Between the text and the training data set the model has learned. Now we've got these two objects. We can use the embedding projector tool to visualize our embedding. To use the embedding projector tool, beautiful. I need to pee. Jiro, what's up? Been studying data science for almost 2 years now. You're a really strong motivation. Oh, thank you so much. You hired as a junior data scientist? Congratulations, my friend. Keep it up, brother. That's amazing to hear. Congratulations. Massive effort. Okay. Can we use the embedding projector tool to see if it works? This is pretty cool, actually. Embedding projector. Let me get rid of all these extra tabs that don't mean jack. Look at this. Whoa. Word to vec. This is word to vector embeddings. So these are different words, all visualized in vector space, embedding space. This is how our computer sees words. So in theory, words which have similar meaning should be close to each other. We need to find two close. Daily, busy. There we go. If you do something daily, you might be busy. Now these are pretty close, these two here. Sealed, dozens. Who's ready to get lost in embedding space? These two are also close. Dropped, born. Speaker. Now, some of these may not make sense to us, but this is how, where did I see that? Battlefield. Some of these may not make sense to us, but this is how a computer sees it. Okay, now let's try our own embeddings. So we can do load. Downloads. I need to delete some crap from my downloads folder. Embedding metadata. Actually, we don't want that. Downloads. Gonna just can all that. And has our file not downloaded yet? You need to allow to download multiple files. Okay. Let's refresh this. And then the metadata. This is what our model has learned. Wow. This is cool. So this is our data. Wonder what the difference is between these two sides. This is how our model is viewing our data right now. Okay, here's two vectors that are really close. Starts, UCO. Again, we might not fully understand why these are close. There's two that are close. Drug remains. You could get lost in here for a while, so just be careful. Dogs and war. All right, so this is how our model is understanding. I'm not sure what's the difference between these two sides. But do you see here how there's 3 dimensions here. I wonder if we could put it only in 2 dimensions. We could do a T-SNE as well. There we go. I wonder if this will be any different. Oh, notice how it's moving? Holy crap. Look at that. They're moving apart from each other. Are they going to keep going? Oh, what are we seeing here? Oh, I didn't mean to click rerun. Okay, so they're starting like this. And they're going to start move away from each other. Let's see what happens. Jero, you're doing a lot of visualizations? That's amazing. I did a lot of visualizations when I first started. Very important. Okay, now let's stop. Look at this. T-SNE has dismembered them into 2 parts. 2 distinct parts. Why is this? This is interesting. And what are these ones in the middle here? Okay, let's get out of that. Come back. This works. Recurrent neural networks. Tokenize, input text, tokenize, embedding, layers, output. Look at this, we're about to build an LSTM. That first epoch took a fairly long time. So the baseline is still crushing it. So this is the power of a baseline. I use Colab Giro because I need to use the same materials that my students are using. So for whenever I'm creating materials for the TensorFlow course, TensorFlow Deep Learning, I always use the materials or the tools that my students will have access to. So for my own projects, I'll be using my deep learning PC. One Convolutional layers can also be used for natural language processing. If you want to do convolutions, use convolutional 1D instead of 2D for text, because text is just a long array of a long sequence, one-dimensional, whereas a picture has width and height. So that's two-dimensional convolution. The baseline is still crushing it. TK, this has to be a slide. Encoder versus decoder in NLP. Beautiful. Look at that. So this is the power of transfer learning with TensorFlow Hub. We can download Google's universal sentence encoder and then put it into our model, build a dense layer on the top, output it to the shape that we want. In our case, it's binary classification. We want one hidden unit with activation of sigmoid. And then we compile it, compiling it like we always do. And then, wonder if TensorFlow binary cross entropy. Does this have label smoothing built in? It does. We might do that for our larger project. And then, how does it perform? Very quick, because we're only training a single layer in our case. But we get outstanding results. So the power of transfer learning is that you can get great results with only a small amount of the data. So if we fit on only 10% of the examples, we still see a validation accuracy of 82 or so percent. So now if we compare the results, isn't that funny? Our TF hub model with only 10% of the data performed the best. There might be something wrong there. That's where it would require How cool is that? Get outstanding results. Then we can view it all on TensorBoard. So the LSTM models are all overfitting on, well, the models we built ourselves are all overfitting on that's really cool. Combining our models. The ensemble performed quite poorly. Better than the other models. The LSTM brings it down. Yes, if you Sheik, if you want to use your TensorFlow if you want to make custom layers, you can use TensorFlow custom layers and models via subclassing. So there you can subclass the keras.layers.layer class. You'll have to initialize it and then implement a call method. This is very similar in PyTorch, but I believe in PyTorch, call is actually forward. So PyTorch subclassing. Yeah, there you go. 2-layer net forward. Very similar. Very similar. But that's how you would make new custom layers if you needed to. Oh, this is cool. That's where the concentration camps and mass murder come in every fucking time. So 1 is a real disaster tweet. So these are the predictions our model got wrong. So that's very valuable. When you can visualize the predictions that your model thinks are one value and has a real high prediction probability for that, but the target label is another value. These are false negatives. So this was supposed to be a real disaster tweet. So this is saying that this is a real disaster tweet. Going to redo my nails and watch behind the scenes of desolation of smog. A. So our model predicted that it's not a disaster tweet. The way you move is like a full-on rainstorm and I'm a house of cards. So that's predicted as a disaster tweet, but the prediction was 0. Or sorry, that's labeled as a disaster tweet, but the prediction was 0. It's not a disaster tweet. Now we can make predictions on the test data set. So this is predicted as a disaster tweet. Rescuers heroically help beach garbage back into ocean. What is this? It's predicted as a disaster tweet. So this predicted as a disaster tweet. It's China's stock market crash. I think it might be picking up on the crash as being a disaster. So there's a bit more exploration that we could go through. Now, how do our model's predictions look on the test data set? It's important to do these kind of visualization checks as often as possible to get a glance of how your model performs on unseen data, subsequently how it might perform on the real test. Tweets from the wild. Speaking of which, how about we find some tweets and use our model to predict whether or not they're a disaster or not. To start, let's take one of my own tweets. Tweets on living life like an ensemble. Daniel's tweet. Life like an ensemble. Take the best choices from others and make your own. Oh, what a great tweet. And the prediction is not a real disaster. Prob. Beautiful. Our model predicted correctly. My tweet wasn't about a disaster. How about we find a tweet, such as 2 tweets about the 2020 Beirut explosions. So there we go. Real disaster, yes. Reports that smoke in the Beirut sky contains nitric acid, which is toxic. Please share and refrain from stepping outside unless urgent. See, that is a disaster tweet. Yes, it is. Another one. Beirut declared a devastated city. 2-week state of emergency officially declared. Lebanon. Looks like our model's performing as expected, predicting both the disaster tweets as actual disasters. That's what we want. One of the final tests we're going to be able to do is to find the speed score trade-offs between our best model and baseline model. Why is this important? Put it this way, imagine your Twitter and this is a very important point as well. Imagine your Twitter and you receive 1 million tweets per hour. This is a made-up number. The actual number is much higher. How many tweets happen per hour? Every second. 6,000 tweets. So 6,000 times 3,600. 21 million tweets an hour. Baseline time per pred. Why is that higher? Oh no, that's e to the power of -5. So yeah, now we're working out what the trade-off score is here. So the time per prediction for our baseline is very fast. However, its results aren't as good. So the ideal, here we go. We need a slide there. Ideal position for dot, top left. Fast plus good results. So this is where you'll have to think of the trade-off. Is if you had this dot or a dot up here, it gets really good results and it's very fast. Wonderful. I think this notebook's ready to push to GitHub. And then we start going back through the TKs. Okay, let's get this onto GitHub, hey? That way you can try it out. What are you doing this week, Ashik? Streaming, are you? Wait, didn't I just save this to TensorFlow Deep Learning? Why didn't that save a copy? Oh, did I save it to another repository? Oh, there we go. It's here. So we've committed that. So this is good. To do. So we need to go back through TKs and fix them up. What slides do we need? Does the text make sense? Alex, that sounds like great fun. I'll be back in a sec. We're gonna get a drink. Wonder if I should make a single page with all the extra resources for the course. Or maybe the model already, the README already has that, doesn't it? Yeah, I think so. So let's runtime. We'll reset the runtime. We'll just go through, we'll start going through and make sure it all runs. How long have I been streaming for? Yeah, k-fold cross-validation is very helpful. Beautiful. So this is how I make materials, right? I do the rough draft and then I go back through it about 5 or 6 times and make sure it makes sense. And then each of the headings is going to be a single video. Or I could just visualize random samples. From a list. No, but then I wouldn't have the labels. To split our training dataset and create a validation dataset, we'll use scikit-learn's train test split method and dedicate 10% of the training samples to the validation set. Boom. There we go. Train test split. Turn this into a link/code. Converting text into numbers. TK, and we need a slide here. Turning text into numbers. Beautiful. Embedding input dimension, yes. Made our embedding. Slide for inputs. You can actually get a very good baseline using multinomial naive Bayes. The first deep model we're going to build boom. So the baseline is better than a shallow deep model. TF-IDF. Import IO. For our next series of modeling experiments, we're going to be using I put the word dog. For example, take two sentences. Massive earthquake last week. No. No massive earthquake last week. Both contain exactly the same words but have different meaning. The order of the words determines the meaning. One could argue punctuation marks also dictate the meaning, but for simplicity's sake, let's stay focused on the words. Beautiful. TK slide, what RNNs could be used for? Yes. So the GRU and the LSTMs don't perform as well as the baseline. That's how I can't stress how powerful TF-IDF is for creating a baseline. Oh, we can add a name parameter to each of them. Okay, we're looking good here. Bidirectional doesn't beat the baseline in this case, Alex. But you're right, bidirectional can be. I think because we're only going on tweets, they're only short sentences. So in this case, bidirectional doesn't win over. It actually performs far worse in the baseline. Renuga, what's going on? Nice to see you here. We're building some NLP code. We've got a fair bit to go through here, but the notebook, well, it's already up on Colab now, but I'm just going through and making sure everything is hunky-dory, and then I'm going to start really making sure it's good to go. I'll finish this notebook tomorrow, and then the day after I will do 09. And then I'll record both those videos, and we'll be one step closer to finishing the course. That's awesome. Glad to hear you're enjoying it. I really like all of your questions on the GitHub too. It helps out other people when they might have a question or something. It helps out you, of course, but it helps out other people when they come to the GitHub. They can already see the questions that you've already asked. I haven't even seen the 360 Ti, 3060 Ti. Is it out yet? When did the 3060 Ti come out? Okay. What? The 3060 has 12 gigs of... So the Ti has more CUDA cores, but the 3060 has 12 gig of memory. If you want to build larger models, I'd go for the 3060. But if you're building smaller models, you probably go for the Ti. Larger models meaning like transformer language models. If you're doing computer vision, maybe the Ti is better. But if you're doing natural language processing, maybe the 3060 is better. Cheers. Jesus. Alex, no, I wouldn't try building my next project on the M1 Mac. I'm probably going to use my deep learning PC for that. Something happened here. But yeah, Alex, you're also right. Tim Detmer's blog post is the best. For GPU hardware. Huh. But then when I predict... Denty, haha, yes. Time series equals data over time. So, like NVIDIA stock price. So this is a time series. So NVIDIA in 2018 were $250, and then they went down, and then they went back up to about 598. You can use a regression model for time series because you're trying to predict a number here, right? In time series, for example, you're trying to predict what the value is on April 1st, given the values all from the past. So you're trying to predict a number here, but you would take in these data points and try to predict the next one based on the past numbers. Yes, I invest in stock, and yes, I have some Bitcoin. $30.60. Wow. Performing better. Mesmerov says, do we need to learn all the mathematics behind it all? Well, it really depends. What do you want to do? If you want to get into research and invent new architectures, I'd argue you do need to learn all the mathematics behind it. But if you want to build things and apply what you've learned, your code, to problems, you don't necessarily need to know all the mathematics behind it. I mean, we've gone through this whole notebook here without a single bit of mathematics. Well, we've kind of used it in our heads for different things, but we're writing mostly code here. But I'd say just follow your curiosity. If you want to learn the math, go and learn the math. If you don't want to learn the math and just keep writing more code, well, keep writing more code, but make sure you rigorously test it to make sure you know if it's going right or going wrong. I think learning the mathematics, though, is always a benefit. That way you can build an intuition from the bottom up as well as the top down. So that's my approach. I learn the mathematics and I learn the code. So bottom up from the math, top down from the code. TL versus custom. What do you mean by TL, Renuga? Have I tried reinforcement learning? Yes, I've tried reinforcement learning. Most wrong, beautiful. Renuga, I'd always start with, well, I'd build a simple model for a baseline and then I'd go for transfer learning. PyTorch versus TensorFlow for the future. Both. You can do basically the same thing in both frameworks. They're very, very similar. That's a great analogy, Alex. PyTorch, like Mac versus Windows. So this is interesting, right? Our better model gets better performance, but it takes 10 times longer to make a prediction. So that's what you got to think about. The better performance is only 2 percentage points better, or 2 F1 points better. However, it takes 10 times more time. That's something you got to think about. Is it worth it? Okay. I think this notebook is ready to polish up tomorrow. So I need to save this. Thank you, Ashik. So we'll just keep it nice and simple. Notebook number 9. I like this. This relates to my last... Look at this quote. This relates to my latest blog post. If I could only copy this, my God. Copy. Don't compete. Just win. So if we go to my website, no competition. Set the system up so you always win. No competition. Competition? No, thank you. That's for losers. I prefer to just win. So this is all saved. I'm going to put this into the GitHub. You can check it all out here. Update text. Make sure code runs. So we've just this should be edited in a second. Tomorrow it's going to be really finished off, and then we'll get on to number 9, which is Milestone Project 2, Skimlit. It's actually a really cool one. But let me edit this. So now, number 8 is no longer coming soon. Then we can go down to the log. Today is the 31st of March. Added notebook 8. Going to finish tomorrow. Then on to 09. Boom. Now, I've had a lot of people ask me when the launch is happening on Udemy. So the update here is once these to-dos happen, these in progress and to-dos, it will launch on Udemy because Udemy like to have all of the code ready, all of the videos ready now. So I wanted to upload it and just do the rest of the sections when I can. But apparently they want everything to be done before it's uploaded there. So we'll continue tomorrow's stream. We're going to fill out this notebook and then we'll get started on number 9. Thank you so much for... It's 45.8. That's probably why it's taking so long to save. Where are you seeing that, Ashik? You know why I think it is? Does it output the tensor board? Why is this 45 gigabytes? You're right. It doesn't output the tensor board. Wonder why that's 45 meg. That could not be 45 megabytes. It doesn't output, there's just text. That's strange. Anyway, I will get some notifications on GitHub. I will see you all later. Have a good afternoon. Thank you for tuning in. And keep learning, keep coding, keep creating, keep moving. Love you all. Easy.